everyone, my name is Sarah Handler.
And I'm Eitan Basri.
And today we're going to discuss how you can build the SOC of the future using identity protection APIs. So we're going to kick off by discussing what is Azure AD Identity Protection. Azure AD Identity Protection enables you to protect, detect, and remediate your compromised identities. When we discuss compromise and risk, what we're referring to is the likelihood that a bad actor has knowledge or control of the identity's credentials and may be using it for nefarious purposes. At the heart of identity protection are the signals that power our risk engine. Our data science team creates heuristic-based detections that integrate into our machine learning system for best-in-class risk detection. We also integrate signals from security researchers within Microsoft, third parties, and law enforcement. This rich risk data is used to evaluate, both in real time and offline, whether users and workload identities are compromised. To best protect your organization's identities, we then provide reporting and automatic remediation capabilities. You can view this data using our Identity Protection Blade in the Azure portal, other first-party security tools, and yes, our APIs. To more rapidly respond to identities when they are at risk, you can configure policies to automatically block, require MFA, or require a secure password change when a risky sign-in or identity is detected. It's important to understand the hierarchy of risk in identity protection. When we think about what makes a user risky, there is a pyramid of risk. So let's look at user identities. At the bottom, we have risk detections. These are specific anomalies that we detect that indicate that that user might be compromised. For example, we might detect atypical travel patterns, unfamiliar sign-in properties, or leaked credentials. Most of our types of risk detections can be traced to a particular sign-in, during which we observe the suspicious behavior. These create risky sign-ins. For a sign-in to be risky, it means that it has one or more underlying risk detections. Both risky sign-ins and risk detections contribute to the overall user risk, which represents the overall likelihood that that particular identity is compromised. At each of these layers, we have a corresponding report in our portal experience, as well as an API.
The hierarchy for workload identities is very similar to what we have for users. We have individual detections on the workload identity, such as a leaked credential, and those compound together to workload identity overall account risk. But Sarah, how do we choose the right interface when we have so many options to get this risk data?
Before we dive into details on our APIs, it's important to understand the different ways that you can retrieve identity protection data. First up, our APIs. These are best for when you want to retrieve the most current information about an identity's risk, or when you want to perform bulk operations that can be challenging to do in a portal. The Azure portal is fantastic for identity admins and security personas who want to investigate in a portal. The same information available here is also in our APIs. Diagnostic settings enable you to stream risk data. For instance, when there's a new risky user or risk detection, this would be sent to your storage account or Event Hub. This is also helpful if you want to use log analytics to create visualizations on top of your risk data. Microsoft Sentinel is a scalable, cloud-native security information and event management and security orchestration, automation, and response solution. You can combine the identity protection data with other first and third-party data sources for analytics, workbooks, investigations, and hunting. Finally, we will soon be releasing identity protection integrated into Microsoft 365 Defender, a unified pre- and post-breach enterprise defense suite that natively coordinates detection, prevention, investigation, and response. So what can you do with the APIs? Let's start with risky users. Risky users provides access to Azure AD users under identity risk. You can use this API to get a user's risk history, confirm a user is compromised, and dismiss risky users. A cool thing about this is that you can confirm a user is compromised even if they've never been risky before. Next up, we have risk detections, which returns details on a specific risk detection. This goes back 90 days of data. This is super helpful if you're interested in a specific type of risk detection, such as unfamiliar sign-in properties, or risk detections of a specific level. Finally, we have risky sign-ins, which returns details on the risk state, level, event types, and details on a particular sign-in. This is helpful to understand why a sign-in was prompted for risk-based policies by looking at the risk level during sign-in property. And you can also use this to understand why risk was remediated or elevated by looking at the risk detail. All right, let's take a look at this demo. So we're going to start with risk detections. When I first query this API, I get a lot of results. So I'm going to narrow it down by filtering to get risk detections where the risk level is medium and where the risk state is at risk. And I'm going to get just where the source is identity protection. By receiving those just with risk state at risk, I'll exclude those that have been dismissed. I'm also only interested in those detections coming natively from identity protection, not the integrated signals. I see that this user Martin has some interesting risk detections. So now I'm going to retrieve his risk history to dive deeper. I see a number of suspicious looking events, and I want to confirm him as compromised, moving his risk level to high so that the user risk policy will kick in. The confirm compromise action succeeded, and when I immediately retrieve his risk again, I can see that his risk level is still medium, but is processing property has flipped to true. That means that the risk engine is processing some sort of change to the risk. After waiting a few minutes, I query it again, and is processing is back to false, and the risk level is now high. The risk detail indicates why this has changed, because I confirm them as compromised. Finally, I want to look at some risky sign-ins. So I'm going to query the API and filter on risk state as at risk. Again, there's a lot of results, so I want to narrow this down. I'm going to add filters for risk level aggregated or offline risk is high, and I'm interested in sign-ins where we detected the password spray detection. This is a much shorter list. If I want to look more deeply at a particular risky sign-in, I can retrieve the sign-in record specifically for that request ID.
So let's shift gears over to risky workload identities for a second. Now, in addition to user compromise, we now address risky workload identities. These are identities that are either connected to an application or a service or some other non-human account that exists within Azure AD. Now, there's two ways that we look at that risk. The risk can come from behavior, that is, behavior of the service principal, which is the security principal within Azure AD that can acquire a token for the application, or something related to the app object, the application object that manages the credentials, or even other properties. Those service principal risk detections and risky service principals mirror what we do for users in many ways. We've simply added the term service principal in front of them. Let's go into the demo and we'll show you what we mean. We'll start with the risk detections. You'll notice that it's actually the same permissions as users that we have for doing this read operation. Now, here I get lots of results from the past 90 days, but let's filter them out, and maybe I want to see it for just a specific workload identity. I can see all the individual alerts for that identity, but here's one for leaked credentials. This means that Azure AD has identified a leaked credential in a public GitHub repository. With that type of exposed credential, I definitely want to take action to remediate it. Now, let's look at account risk by calling the risky service principal collection and filter on a specific service principal. One thing to note is that there are specific permissions for this collection. Those are identity risky service principal.read.all and identity risky service principal.read_write.all. And the first one lets you read the risk state of the workload identity. The second one lets you either dismiss risk or confirm compromise of that identity using a post operation. So we have the specific object ID of the account that we want. I can see that it's at risk, and the state is not processing. Now let's say I determine during my investigation that the account either was not compromised or it has been remediated. This is where I want to dismiss the risk. So I make the call, I get a 204, which means it was successful. If I make a GET call on that account, I can see that the risk is now processing. And if I wait a few minutes, that property will update, and the risk will now be dismissed. Sarah, what are a few other notable APIs that we should be aware of as we're looking to secure our identity infrastructure?
There are some other important complementary APIs that can help you be successful with identity protection: conditional access and named locations. The conditional access APIs allow you to easily create policies that can be triggered by sign-in risk, user risk, and workload identity risk. You can configure these policies to block, require MFA, or prompt a secure password change when these types of risks are detected. This is super important to ensure that our customers and you are quickly responding when we do detect risk. The other component is using the API to set named locations. Named locations allows you to configure certain locations and mark them as trusted so that we take that feedback and can cut down on the false positives for atypical travel and unfamiliar sign-in properties. If you're noticing a lot of noise in identity protection, this can be a great step to cut down on it. So Eitan, what should we do next?
Okay, let's talk through some takeaways. First of all, there are 5 key collections to be aware of within Graph for interacting with identity protection. Some of them allow you to read information, some of them you can write to. It's important to know how to interact with each one depending on what goal you have. If it's all about just collecting all the alerts, you need to get the risk detections. If you want to be able to dismiss and confirm compromise, then you need to be reading and writing against risky users and risky service principals. Now, conditional access is a very, very important aspect here, because while it's really important to have the risk detections and all the risk reporting, where this all really comes to life is with conditional access and risk-based policies in conditional access, where you can, in real time in many cases, control access and contain compromise by using that automatic engine.
And the most important thing is that you can get started right now with these APIs. We have robust documentation on how to use these APIs. We have a number of sample scripts for common tasks that you might want to do with our identity protection data. And you can subscribe to updates about identity protection, including our APIs. Thank you so much for joining us today.
Stay safe.